Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
Today, we're tracking a visitor from far beyond our own solar system. It's on a collision course with our sun's intense heat, and we're asking a question that sounds simple but has a very complex answer. Is it going to survive the journey? You see, comets, these ancient travelers of the cosmos, they aren't invincible. They're actually quite fragile, like relics from when stars were first born. And a close encounter with a star, well, that can often be their final act. The interstellar object we're talking about is named 3I/Atlas, or 3I Atlas, and it's heading right for the heart of our solar system. Its upcoming pass by our sun is going to put its very existence to the test. So will it hold together, or will it shatter into a million pieces? The big question here, posed by astronomer Avi Loeb, is whether 3I Atlas will actually disintegrate as it gets close to the sun. To really understand the possibilities, we first have to look at the incredible destructive forces it's about to face. Okay, the key date here is October 29th, 2025. That's perihelion, the moment the comet makes its closest approach to the sun. At that point, 3I Atlas will be about 203 million kilometers away, getting blasted by the sun's intense radiation and gravitational pull. It really is the ultimate stress test for this interstellar visitor. So what exactly could destroy a comet like this one? Well, science has pretty much identified three main culprits. Three things that can cause a comet to just catastrophically break apart. So let's break these down. First, there's the sheer heat from the sun. Then there's the force from its own spin, kind of like a spinning top. And finally, you have the powerful gravitational pull of much larger bodies. Any single one of these can be a potential comet killer. So first up is what we call thermal stress. As the comet gets closer and closer to the sun, its icy surface heats up incredibly fast. But the ice doesn't melt, it sublimates. That means it turns directly from a solid into a gas. This explosive release can create immense pressure from the inside, literally cracking the comet's fragile structure apart. And all that escaping gas? Well, that leads us right to the second mechanism, rotational stress. You see, those jets of gas don't fire off evenly. They act like tiny, misaligned rocket thrusters, pushing on the comet and causing it to spin faster and faster and faster. If that spin gets too quick, the force can literally tear the whole thing apart from the inside out. And believe me, we've seen this happen before. A comet called 332P is a perfect example of an object that fragmented because it started spinning too fast. But for our third mechanism, tidal forces, the most famous case is probably Comet Shoemaker-Levy 9. The story of Shoemaker-Levy 9 is just an incredible illustration of tidal forces. Back in 1994, the whole world watched as it got too close to Jupiter and was ripped into a string of 21 pieces by the planet's massive gravity. It wasn't heat, it wasn't spin, it was a gravitational tug-of-war that the comet tragically lost. Okay, so how does any of this apply to 3I Atlas? We know the forces that could destroy it. Now, let's take a look at what the evidence is actually telling us about its current condition. And here's the crucial point. Despite a lot of careful observation, astronomers have not yet confirmed any fragments breaking off from the main body. So for now, the comet appears to be completely intact. You know, a breakup would leave some really clear signs, like smaller objects suddenly appearing nearby or the comet flaring up in brightness. And while some images have shown some faint little features around 3I Atlas, the general thinking right now is that these are probably just noise in the data, not real, genuine fragments. So, with the evidence for a natural breakup still pretty inconclusive, the source of our analysis, Avi Loeb, brings up an alternative, pretty speculative idea, one that kind of pushes the boundaries of our investigation. In this scenario, any little objects we see near 3I Atlas wouldn't be natural fragments at all, but something else entirely, maybe technological probes being deployed from some kind of parent craft. Now, it's an extraordinary claim, and it's presented purely as a hypothesis that needs to be tested against whatever data we get in the future. So whether the explanation is natural or not, the key is just more observation. The scientific method demands evidence. So what exactly will astronomers be looking for as 3I Atlas makes its closest approach? The checklist is pretty clear. First, Are there any new, smaller objects traveling along with it? Second, its brightness. A sudden flare could be a sign that a fracture has just exposed a fresh, icy surface. And finally, its tail. Any change in its shape could mean a change in how gas and dust are escaping, which would point to a breakup. And we have a definitive timeline for this whole search. After that October 2025 perihelion, the European Space Agency's JUICE spacecraft will get a look in November. Then, all through November and December, powerful telescopes here on the ground will turn their eyes toward it, monitoring for any of those telltale signs. And there's one more layer to this. Loeb's own Galileo project will be scanning Earth's atmosphere. They'll be watching for any unusual objects. Just in case any of those hypothetical mini-probes happen to head our way. It's a really comprehensive search for answers. So, where does all this leave us? Well, we have a mysterious object from another star system, a set of physical laws that just might tear it apart, and a global network of instruments ready to find out what happens. The final verdict on 3I Atlas isn't in yet. We just can't say for certain if it's going to survive. But that uncertainty, that's the very essence of scientific exploration. We don't have the answer right now, but we have a rigorous process and a very clear set of clues to help us find it. And this, right here, is why it all matters so much. This object is like a time capsule, a physical piece of another solar system delivered right to our doorstep. So whether it stays whole or shatters into pieces, the observation of 3I Atlas is a huge win for science. It's a priceless chance to study interstellar material up close and to better understand the fundamental forces that govern these amazing celestial travelers. This explainer was based on the analysis of Avi Loeb. Thanks for watching.